Hi, everyone. This is the scientific method, the true origin of DevOps. I'm going to just quickly go through this. Another quick lightning talk. My name is Wesley Faulkner, as Maddie said. I'm the head of community at Single Store, and this is a boring slide, so we'll just keep moving on to the next one. The scientific method is the empirical method for acquiring knowledge that has been characterized the development of science. It's in DevOps, we solve problems every single day. We're on the cutting edge of what's possible with the use of technology. Sometimes in order to look forward, we need to take a step back and look at the past and see how the people before us tackled very hard problems with new methods and new approaches. And sometimes they did this in isolation or extremely stressful situations. Sound familiar? So as we tackle through this pandemic and as we bring in new technology, it's very interesting at how they did it then. And let's see what we can steal for the current time. All right, so let's look at the scientific method. So there is no one single scientific method, but here's just one example. You ask a question, you do some background research, you construct a hypothesis, you test your hypothesis by doing an experiment. You analyze the data and draw a conclusion. And then after all of that, you communicate your results. So it's pretty straightforward way of being able to take something from the start to the end. And it feels like duh, but keep in mind, we didn't even have this tool for so much of our history. Now let's look at the DevOps lifecycle. You plan, you code, you build, you test, you release, you deploy, you operate, and then you monitor. Now, if we look at side by side, you can see there's a very strong correlation between these two steps. Very similar, and that's what gave me the idea for this talk. I researched the history of three founding fathers of what we now call the scientific method for inspiration. Their lives and their work are very fascinating, and they all lived around the same time period. So that's what we're going to talk through. So we have Galileo of Galilee. Galileo Galilei, born in Pisa in 1564. He considered becoming a priest. He studied art. He attended school for medicine. Then he attended a lecture on geometry. That's when he decided to study math in secret because his dad wanted him to focus on medicine. He eventually became a professional mathematician and professor. He became, in 1593, a ballistics consultant for the Arsenal of Venice. Can you believe that? He just shot cannons and stuff. He then, in 1609, built and refined telescopes. He didn't invent it, but he did refine them. And then through that, we can see that how good instrumentation can change the limits of what we can do. Researching the night sky, he learned that Copernicus was right and that the previous ideas were not in line with actual what he observed. In 1611, his name was brought up by the Inquisition. In 1615, after receiving criticism about from one of his patrons, he wrote that the Bible and nature do not disagree here. One is God's words, the other is God's work, and science is uncovering the actual work. In 1616, the church put Copernicus's work, put that on the banned list. So no more Copernicus. Heliocentrism was outlawed. In 1623, Galileo published the pamphlet called the Essay. Scientists should be able to do their work, is what he said. Pope Urban VIII was totally in his camp, and when he published 1632, the book on dialogue between the two chief systems, the Pope actually said, I'm fine with it, just as long as you treat both systems exactly the same. He didn't. And in 1633, he was put on trial for the Inquisition and he was placed on house arrest. But he kept going. And in 1638, two new sciences. He wrote about how bodies fall through the air and how wood breaks. And what he did that was revolutionary is that he showed his steps because he wanted people to be able to recreate what he did. So thank him for RTFM. And then we have Francis Bacon. He was born in London in 1561, and he got mistaken for Shakespeare a whole bunch. Most of the impact on science he had was posthumous. Now, his work was supported by the state. He wanted to create a whole replacement system for natural science. He wanted to combine philosophy, mathematics, physics, biology, all together, kind of like a United Nations of science. Now, he rejected Aristotelianism, the way he did science. He thought we should do humanity a justice by making technological advantages. He still expressed this in a Christian framework. So he says, if it's Christian, we're helping people, and the people who did science without helping people, they kind of went off the script. And so he wanted to understand and control the chaos of nature. So what does taming nature look like? Gunpowder, silk, printing press. These are just some of the examples. So control over nature, which is not possible. I mean, look at global warming. But he just wanted to do the work. He wanted not just to figure out how things worked, but he wanted to create a whole system for people to figure out how things worked. His major contribution was like testing assumptions and not trusting old books. He wanted just to experiment. In 1626, The New Atlantis was a book that he wrote that's a utopian science bureau, a hub of intellectual work. It's called the Solomon House, was a place where people worked and people traveled, gathered facts, did experiments, and then they would write them down and just basically figure out new inventions from that. Have you heard of Scrum? It's kind of like that, top down. And then René Descartes in 1596, he was one of the founding figures of modern mathematics and modern philosophy. He bridged geometry and algebra together. So if you've heard of the Cartesian coordinates, X, Y, Z axis, that stuff, that's for him. In 1633, because of what happened to Galileo, his publisher stopped his own Copernican book and the Le Monde, also known as The World, so that never got published. In 1637, Discourse on Methods was how he put together and redefined epistemology. Philosophers today are still debating some of the questions that he asked there. He wanted to dethrone Aristotle as the king of philosophy. He created this new system called systematic doubting. Doubt your own senses, doubt your own reason. The only thing that you could be sure about are the things that can be proven with math. When in doubt, doubt yourself. This analytical rigor is what basically made his own brand. Now, if we look at these three, Galileo, Bacon, and Descartes, Galileo's focus on independent rational comparison theories about natural phenomena, Bacon's focus on experimenting and social norms promoting science and research, Descartes' reminder to always doubt and always test, you can see a certain kind of method forming. Now, there's no one scientific method, but they all have rationality, experimentation, and ruthless self-examination. And if you are wondering why you're doing what you're doing, question it, doubt it. Most of the tools that you're using weren't in existence 15, 10, 5 years from now, years ago. So go ahead and create new systems, question everything, and figure out for yourself why things are the way they are. Thank you. And if you want to get in touch with me, you can reach me on Twitter, or you can hit me up on my site at wesleyfaulkner.com. Thank you for your time. Back to you, Maddie.